future hackers and high earners. In this section, we're actually going to cover Linux permissions. I got to tell you, Linux permissions is one of those things that's little understood, albeit a very simple system. It's one of those things that people run from. They don't fundamentally understand the power of Linux permissions, the power of having admin privileges and being able to impact the permissions of your files and directories. Additionally, understanding Linux permissions allows you to control the security of your box. Believe it or not, all of the security tools in the world at some point execute the actual commands that are in your user bin directory or user local bin directory. So there might be a nice veneer, a user interface on top of everything, but fundamentally they're executing the commands that you're learning in all of these particular sections. Now, to fully understand the permissions, or I should say understanding the building blocks, we want to take a look at a command called chmod. And you know how we do it here. We use the man page so that you don't have to go to a web page. It's very important for you to understand and read these things for yourself. These man pages are written by the original authors. They're typically very well written. There's a plethora of information contained in the man page. And again, reading the man page so you don't have to go to the web page. Some of this looks very dense. Sometimes you look at these man pages, they could be very intimidating, but I can tell you this, you don't read these once, you read these several times. And the best way to actually learn is to read these several times and try. So it's a combination of read and try, read and try. It's just the way that it is. You got to get your fingers on that keyboard, get your fingers dirty, and try some of these things. Luckily for you, I've condensed those man pages into something that's easy to digest. Here, I'm on my Ubuntu instance on AWS, and we're simply going to play around with chmod, and we're going to understand. And again, this is how you change the permissions. Let's look at the permissions first. If we look at the permissions here, we just do an ls, and we see some line items here have a dash, some line items have a W. The D is for directory. Some have a D in the beginning and some have a dash in the beginning. The D is directory and the dash means file. They just decided. They needed a character representation. They decided on a dash, could have been anything. But in this particular case, we know the difference between files. These are test files that I just created using Touch and dropped in here for the purposes of this particular test. Let's focus on one of the files. Let's look at blah. And let's understand these permissions. So the way these permissions work is very, very interesting, fascinating. They're so simple, it's brilliant. So the first three bits here, the R, the W, and the X, represent the user. The second three bits, the R, the dash, and the X, represent the group. And the third three bits represent, the R, the dash, and the X represent other. So you have user, group, you have other. Rather than drawing you a diagram, I'm just going to teach you the whole course here on the command line. So user, group, and other. What this means for the actual blah file that you're looking at here is that the user has read, write, and execute. The X is for execute. The group has read and execute, but no write access. And then other, same thing, has read and execute access, but no write. So phenomenal system. And what we'll do here is we'll show you the actual shorthand first and show you how to impact the actual permissions yourself. So what if we wanted to add write access to the group? How would we do that? For whatever reason, we're the administrators here and we want to add write. So I would use chmod and I would do G plus W on the blah file. And the way this reads is, think of chmod as change permissions for now. Change the permissions on the group, plus sign, add write access to the file blah. Let's hit enter. And now let's look at the permissions. Notice that the second three bits is now RWX. To repeat, because this helps sort of pound it in your brain, the first RWX is read, write, access for the user. The second RWX is read, write, execute access for the group. The last 3 bits, read, no write, and execute for other. So let's go ahead and add write access for other. Let's go back here. Instead of the G, let's be super fancy and add the O. Now we're adding write access for blah for other. Let's look at this file here. Now we see RWX, RWX, RWX. So user, group, and other all have read-write access. How do you take permissions away? Super fancy. Let's use the minus sign, and let's take away from other. Let's take away execute access. So this says change the permissions for other, minus sign, take away the actual X, the execute permissions for blah. Let's hit enter. And there you have it. You now see RWX for user, first 3 bits, RWX for group, second 3 bits, and RW and a dash for other because we've just taken away execute. Let's do one more before we move on to the numerical system. So let's take away read access for the group. Right? Change permissions for the group, minus sign, take away read permissions for blah. Let's take a look at the file here. You'll now notice that the first 3 bits, RWX for the user. The second 3 bits, notice R is not there. There's a dash in place of the R, so there's no read, yet there is write and execute. And then we have RW and dash for other. So this is the great shorthand. This is an easy way for you to remember, to pound it in your head. RWX, read, write, execute, user group other, user group other. All you need to remember at this point. Now let's think about the numerical system. So the numerical system for old school people is something that we all grew up through the ranks. It's what I learned in college. It's what I've been using professionally throughout my career for both software development and DevOps. And back when DevOps was called IT and automation, you had to understand the numerical system. So here's one way to think about the numerical system if it's something that you choose. What we just did before with the shorthand will work, but let's take a look at for a second at what the numerical system means. Assign a value of 4 to read. Let's think of write as 2, and let's think of execute as 1. Now this is an interesting system here. I'm not going to use any fancy graphics. You're going to be top the command line on the command line because that's just the way we're getting down. So if you look here, R has a value of 4, which is read. W has a value of 2, which is write. And X has a value of 1. Let's just execute. Let's look at and make a change here. It's better looking at an example. What if I do chmod, change the permissions, make the permissions 644 individual digits for the file blah. Now remember, if you look at the permissions on the file, user group and world, you'll see that the R is a bit, the W is a bit, the X represents a bit for each of the respective sections. So for user, group, and other. So what we're saying here when we chmod 644, the 6 is for user, that first 4 is for group, and that last 4 is for other. So we're telling it what to do. But let's look at our values here. We've said, how do we get 6? So if we look at the system here, we see that R is 4, W is 2, 4 plus 2 is 6. So we're basically saying for user, give that user read and write because those are the bits that are impacted. For the second one, we see a 4 here. What does that mean? So if 4 is on, that means read access only because if you add any of these other bits, you don't get 4. So that means the second digit, the first 4 here, is for the actual group. That means that the group will only have read permissions. Not surprisingly, if you have a 4 for the last one or other, it means that other will only have read access. Okay, so what we expect to see here is read write for user and read for group and read only for other. Let's see if that worked. Oops. We want this instead. So we see that we have in the first 3 bits, we have read and write, and no execute for the user. We have read for group, and we have read for other. Let's do another one to sort of hammer this home. Let's go here. What do we expect there? So going back up to our system here, we see that RWX. So to get 7, which represents the user, the 4-bit is on, the 2-bit is on, the 1-bit is on. 4 plus 2 plus 1 is 7. That means we're giving read, write, and execute to the user. For the second digit, which represents the group, we see how do we get 5? We get 4 plus 1, which is 5, which means R is on, X is on. So that particular group is getting read and execute. Same thing happening for the last group, or for other. So let's take a look here. Now we see we have read, write, access for user, read and execute for for group, and read and execute for other. So we've just impacted the permissions using a numerical system. And again, this little key here, 421, R equal 4, W equals 2, and X equals 1 is actually a good way to sort of memorize, commit it to memory. We go over binary later in one of the later courses, but this is just a good key here. Also, what happens with a directory? So we have a test directory already created here. Again, if you wanted to create a directory, you would use makedir, which you've learned in another lesson here. But notice that for this particular directory here, let's just do it this way. Let's look at only the test directory to make this a little simpler to look at. We look at the test directory here. We see D signifying directory. The user has read, write, and execute. The group has read, write, and execute. And other has read and execute. What does execute mean in the context of an actual directory? X means that you can change directories. You can go into the directory. So it means that I can cd into test directory. If I didn't have that execute permission on that directory, I would get permission denied. Linux would vomit up an error for me. So those are the basics. And again, these are building blocks. The power of Linux and the operating system is that all these micro programs, all of these things have a lot of power. But as you learned in another lesson, you can combine all of these things together. These are the basics. My recommendation is spin up a Linux system, a virtual machine, make files, change the permissions until you get comfortable with it. You're going to have to get your fingers dirty to get better at this, but this should give you a good start. There will be a cheat sheet for the permissions, my personal cheat sheet to sort of help you through your journey for permissions. Good luck.